Hello there, welcome back. In the previous lesson, we learned about Node.js and we went further into the history of Node.js, why we should use Node.js and the key features of Node.js. This video will explore each key feature starting with event-driven architecture. Node.js operates on an event-driven, non-blocking I/O model, fundamentally shaping its architecture and performance characteristics. Three important concepts makes up the event-driven architecture of Node.js, and they are the heart of Node.js, which makes them very important to learn if you want to become a great backend engineer with Node.js. The first one, we have event loop. Next, we have non-blocking I/O. Lastly, we have asynchronous programming. The event loop is at the heart of Node.js, a mechanism that efficiently manages asynchronous operations. Instead of waiting for I/O operations to complete before moving on to the next task, the event loop delegates these operations to different components, such as Chrome V8 engine or libuv, depending on the operation, and continues executing other tasks. Once an operation completes, the event loop triggers the associated callback, allowing the application to process the result asynchronously. Exploring everything around the event loop is a broad topic, and we'll go on a detailed ride on the event loop in a separate video. However, let's look at how non-blocking and asynchronous programming is made possible in Node.js by the event loop. So first, non-blocking I/O is not a programming pattern or methodology. It is a concept in programming that promotes the idea of performing I/O operations, that is, blocking or synchronous operations, in an asynchronous pattern or non-blocking. Node.js employs a non-blocking I/O operations concept, enabling it to handle multiple concurrent requests without blocking the execution thread. This approach maximizes CPU utilization and minimizes idle time, leading to better performance and scalability. Developers can perform I/O operations such as reading from files, making network requests, or accessing databases without waiting for each operation to complete, thus ensuring the application remains responsive under heavy load. Then when these operations are completed, the results will be passed on to the user using callbacks. Next, let's talk about asynchronous programming. Node.js promotes a synchronous programming pattern, allowing developers to write code that efficiently manages I/O operations and other tasks. Developers can orchestrate asynchronous operations and handle result non-blocking by using callbacks, promises, or async and await syntax. This asynchronous programming model is well suited for building highly responsive and scalable applications, particularly those with high concurrency requirements. Throughout this course, we will use asynchronous programming syntaxes such as promises, callbacks, and async await syntax. In this video, we explored the event-driven architecture, where we discussed the non-blocking I/O model, and also we talked about asynchronous programming. We also went further to talk about promises, callbacks, and async await syntaxes, which are used heavily in asynchronous programming. So in the next video, we are going to talk about single-threaded. So see you in the next video.